we will graph the logarithmic function in a moment here, but let's just talk about one other type of problem that they might throw at us here. Let's evaluate this for a couple of values. Number one, x equals 8. Evaluate this logarithm for x equals 8. Well, same old, it's just plugging in x to be whatever case may be there. Now, we just have to figure out what that value is, and it's the same thing that we're doing, wasn't it? This equals what number? So 2 to what power gives me 8? Third power, isn't it? So this value is 3. We go to x equals 1 over 512. So the x is 1 over 512, so evaluate that. So it'd be log base 2 of 1 over 512. So again, what does it equal? 2 to what power is my 1 over 512?
Negative number.
It's got to be a negative number, yeah, because it's a fraction, so it's got to be a negative. Just have to figure out 1 over 512. Doesn't sound good to me there, but is there a value of 2 that gives me 512? Power 2. Yeah.
Bigger than 5.
It's bigger than 5. 2 to the 7th is 128. 2 to the 8th is 256.
2 to the 9.
It's 9. 2 to the 9,
Negative
yeah.
9.
For some reason that just didn't sound. So yeah, 2 to the 9th is 512, so what's the answer here? Negative 9. So the value here is negative 9. All right, so yeah, that's just same problem, just in a different context or a different format. Now, there are a couple of logarithms that are named, I guess you might say, and one of them is called the common logarithm. And the distinction of the common logarithm, it's the logarithm base 10. Logarithm base 10. So it's given a name, and it's also given a special designation. It's denoted log of x. Log of x. The special designation of that is what's not showing up there. There's no a, right? There's no a. There's no base written there. So it's understood to be, since it's logarithm base 10, that's understood to be base 10. Okay, so if we just have log and there's no base, it's understood there that to be base 10. Okay. Now the nice thing about the common logarithm is, most calculators are not going to have a base 2 logarithm, but some do, but most don't. Okay. Most calculators, scientific calculators, have this common logarithm displayed on the as one of the functions there. And so what that means is, if I've got log of 1,000, all right, that one's doable by hand, I guess we might say, because what this means is there's no base there, so it's base 10. 10 to what power is 1,000? Third power, isn't it? 10 to the third gives me 1,000. All right, so that's 3. But if I have log of 500, 10 to what power gives me 500? Well, that's not a nice power of 10. 10 to the second is 100. 10 to the third is 1,000. So I skipped right over 500, and it's not going to be 2.5 either. But with our calculators, just find your LOG button and go log of 500, and it tells me it's 2.698, and however many places we want, up to a certain point anyway. Mine has this many. I'm sure there's others after that might be rounded for, but, all right? So yeah, it's not a nice power of 10, but the calculator can do it for us, okay? So that's the nice thing about the common logarithm. Also, we have the natural logarithm. And if you remember, we talked about the natural base. What was the natural base? It was base e. Yeah, natural logarithm is logarithm base e. So it's just like the natural base, and that we call it the natural logarithm. And it's denoted, so it has a special notation for it as well. It's ln, for obvious reasons, probably there. Ln of x. So if you've got a ln, that's base e, okay? And I think they'll have you do one like this. All right, so say we've got ln of 5 equals 1.6094, ... What's that in exponential form? So going back to, converting back to exponential form, I've got the value of the logarithm, but what would that be in exponential form?
E equals 5.
E to the y,
To the power of.
1.6094, ... equals 5, right? A to the y equals x. The base here, the a it's not written, but it's understood that it's base e. So if you convert it to exponential form, the base here is e. That's the a. Okay? That's what you have to understand there. All right? But again, these are nice because, I mean, they're not at all, unless you have a power of e, but they're not at all nice numbers because, yeah, you're dealing with base e, which, remember what e was? What number was e? 2.71828 was the first few decimal places of it. That's not at all a nice number, but the calculator can do it for us, all right? Because most calculators have, scientific calculators have an ln button. ln of 500, no problem. It's 6.2146, blah, 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 okay. You can just punch it in and get those. All right?